Hi, I'm Bob Abel, one of Richard's students from '89 to '96, and a collaborator for 9 years after that. These days I teach physics at Olympic College, and on the side I work on software for the Large Synoptic Survey Telescope. But way back in 1989, I was an engineer at Rocketdyne in the Valley, working on rocket engines and finding that even humans can build some pretty amazing machines. I was more interested in what nature does. Space physics seemed interesting, especially after meeting Richard. So I started taking graduate courses part-time and eventually full-time. For my master's thesis, Richard suggested we study the inner radiation belt population over a long period of time to see how it was affected by the 22-year solar cycle. And we had charged particle data from detectors flown on satellites between 1966 and 1991, thanks mostly to Al Van Pola. And we found solar cyclic effects, but our biggest find, it turned out, was not of natural origin. Nuclear weapons detonated in the upper atmosphere around 1960 by the Soviets and Americans injected a mess of charged particles into the inner radiation belts, killing satellites in the process. Now, the models at that time assumed this radiation had disappeared within 5 years, but we found its spectral signature was still visible 25 years later, a distinct man-made modification to the inner radiation belt, a volume of space much larger than our atmosphere. So for my dissertation, we looked at how radiation belt particles interact with electromagnetic waves. Charged particles travel in a helix around a magnetic field line, and if they encounter waves with just the right wavelength and power, they can surf them into the atmosphere. So we included natural waves we knew were present, plasmaspheric hiss, and whistlers. Whistlers are waves produced by atmospheric lightning. We also modeled very low frequency VLF transmitters some nations use to contact their submarines around the world. We figured they didn't do anything, but we wanted to be thorough. They turned out to have a huge effect, the predominant source of particle removal in some regions. So here's the figure, our last figure in that paper. Shows how particle lifetimes on the vertical axis depend on their distance from the Earth's atmosphere. That's Earth radii on the y-axis. The top line is how long particles will survive if there are no waves, just collisions with other particles. The second line down, we added hiss, and you can see the lifetimes diminish. And then we add whistlers, and they diminish more. Finally, we added the submarine transmitters, and you can see where the data fits. Matched it just amazingly. Bam! That's a PhD right there, baby. This is the best lesson I've ever had about the knowledge of the importance of knowing what's true and what you're just assuming. And if it's an assumption, what's the reasoning behind it? These transmitters have been in operation since World War II, so we've never even seen what our natural radiation belts look like. I left engineering to study nature, and yet we discovered another man-made signature in Earth's inner radiation belts. At the same time, though, we developed a mathematical solution for finding the right frequency and intensity of waves to clear the radiation belts of satellite-killing radiation in the event of another nuclear detonation. Instead of lasting for decades, these particles could be removed in days. This became a very popular paper. Currently, it's like some 320 citations for the two-part paper. And it spawned a cottage industry with support from the Department of Defense. The thing I like best is that it can only be used for defense. Richard makes it easier to take criticism because he's right so much. Usually his suggestions require a lot of extra work too. But it always turns out to be worth it. He's also very good at giving feedback, copious amounts of feedback. This is a first draft of our first paper. We'll just flip through a few pages so you can see it. It's a relatively famous paper, but you can see all the handwriting in there. Any fellow grad students in there recognize that handwriting? Yeah, you do. I saved it all these years for this very day to thank you, Richard, for impressing upon me how important it is to solicit feedback and then to utilize it. I pass that lesson on to my students every day. You know, this space physics stuff is all cool, but whenever I think of you, my first and strongest impression is always of our friendship. We got along from the very start. I can't remember a cross or even impatient word between us. And the only disagreement I remember was the time I thought you deserved to be lead author on a paper and you thought I deserved to be lead author. And it wasn't like we were working at it. We were just comfortable with each other, and even each other's families. Our conversations were this great mix of science and life, with a focus that never obstructed humor. Learning's never easy. I hate learning. I like knowing stuff. but you made it easier. Thank you for always being such a good friend, Richard, and as one of your many students, thank you for taking such good care of us.